to the spreadsheets here. Worksheet 5.2. All right, so go to the two-way tables. We're going to go to the census data. Okay. And let's just get the totals. And totals here. Okay. So, probability that someone is widowed given that they are female. I'm going to pick on Brandon. Brandon?
Yes.
He's Brandon. Doggone it, I got it before class.
Yeah, that's it.
Brendan, okay. So, what do you think on that one? How do you figure that out?
So widowed or female?
Widowed, so that line means given. So we're doing this one here. Probability that someone is widowed given that they are female.
I'd take the total of the widowed females, 11.3,
11.3
divided by the total females.
divided by what?
Total females?
Total
So,
females?
113.
Okay, so essentially that was right. Okay, essentially what we've done is we've limited our sample space to only this column now. Okay, does that make sense? So the given says, I don't care about males anymore, I only care about females. Okay? So about, looks like about 10% of women, or excuse me, given that someone is female, 10% chance that she is widowed, according to this data. Okay? How about the probability that a random male has never married? Now that's a little bit different format, but it does, this is another condition of probability. So, Sam, how would you do this one?
Okay, we're due. Okay, so we narrowed it to the male column.
We've narrowed it down to the male column. I'll pick another color.
We don't care about anything else.
Okay.
Okay, so random male has never married. So I would take the total number of males. No, I would take never married divided by the total number of males. Is that backwards?
Okay, so what numbers am I clicking on?
I would click on 106.2. And I'd divide that by 30.3.
30.3,
Sure.
3.5, is that correct?
That's backwards, Dan.
Yeah, because it can't be greater than 1, right?
Correct.
Okay, let's try that again.
So I would do 30.3 divided by 106.
Here we go. So Sam demonstrated a nice technique to know you've got the wrong answer. Okay, so you should pay attention to that. If you get a number like 3.5, that can't be right. Not even close. Okay, then you just flip the numbers. So very good troubleshooting technique there. Okay, how about what do I pick on? Oh, Krakova, you're here. I didn't see you. I still got your quiz from yesterday. How about the probability that a never married is male? Divided by what? 55.3. So you're looking at the row. It's a good thing to look at. Okay, so I should color code these, right? So this time he's limited his sample space to the row it never marries instead of to the columns. So that's your orange one. And this one is the row. Okay, does that make sense? Okay. Not too bad, right? It's like it's a lot easier than using this dumb formula, right? use that formula now though. What if I said, okay, this is a good one here. What if I told you in 2005, 12.64% of all births were preterm. And what we mean by preterm is less than 37 weeks. Okay? Also in 2005, 0.22% of all births were overweight. And what we mean by that is greater than 8 pounds, 13 ounces. Okay? So what is the probability that a baby is overweight given that the baby is preterm? And then the next question is this unusual? Okay? So just as a reminder here, I'm going to ask Josh, what does unusual mean?
Less than 5%.
Happens less than 5% of the time. Okay? We're going to call that unusual. Okay? I'd pick on Katie, but I know she's having a hard time seeing, so I'm going to pick on Clara. Okay? Let's talk about this. Okay? So we're doing our conditional probability here. Let's make these match my formula here. What is this event called, according to my formula? I can't hear you.
I can't read that.
What is the probability that they're overweight given preterm? So what letter should I represent that by?
Oh, S.
That's letter F, and this is letter
E.
E. Okay, so if overweight is F, then this is also event F, and this becomes event E. Correct? Okay, that's going to be very helpful for figuring out this problem. Okay? Because we want the probability of F given E, which in this case is just what I asked for, probability that they're overweight, given that they're preterm. Okay? That's going to equal the probability of E and F divided by the probability of E. And the probability of E is preterm. Okay? And we're saying preterm and overweight. I'll just abbreviate that one up here for overweight. Okay? Okay, so this is what I'm looking for. Now, let's do this one because this is the easy one. Probability that the baby is preterm is what, Clara? 12.64%. I'm going to convert that to a decimal, so I'm going to go 1264. Okay? Now, here's the part where people get a little confused. Okay? Now, remember here it says preterm and overweight. Okay? Now, it says 20.22% of all births are overweight. That would include the preterms as well. Okay? So this one's an and, believe it or not. So that would be 0.0022. So that's really an and. Because we're saying that, yes, that applies to both. Okay? So we punch that in our calculator and we should get 0.0174 or 1.74% of babies are overweight given that they are preterm. And Ryan, is that unusual? Is it unusual for a baby to be overweight given that they are preterm? Because it's less than 5% of the time. Does that make sense? Okay? These are fun, right?
So,
Cooper.
why wouldn't you do 0.0022 plus 0.1264?
Okay, so if you're adding them, what are you assuming?
That they're mutually,
You're assuming that they're mutually exclusive. Are they mutually exclusive? No.
okay. So if they aren't mutually exclusive, we would do that.
If they are not mutually exclusive, we're going to use this rule.
Okay. So we do 0.0022 plus 0.1264 divided by 1.1264.
No. We're going to do our conditional probability rule. Okay. Now we're saying, that 0.22% of overweight babies are also preterm. Okay. So that's the one thing. That's the hardest part that people have a problem with. We're saying that applies to preterm as well as regular term babies. So that's
So how do you know that that applies to?
because you do this 100
overweight?
times and you learn. What'd you say?
I said this is all births.
It's all births, yeah. It does say all births, which would include preterm ones. Okay? All right. How about this one? Oh, let me ask you a question. Okay? Can you solve for probability of E and F? Who haven't I picked on in a while? Jared, I haven't picked on you in a while. You think that's possible?
Maybe.
How would, if it were possible, how would you do it? Just a little bit of algebra. You would do what? We're trying to solve for just this. You multiply both sides by,
Oh, 1 over
no, you multiply both sides by the denominator, right? Okay, that actually gives you the general multiplication rule. Okay, so the general multiplication rule is basically the same rule, only I'm multiplying both sides by the probability of E. So the probability of E times the probability of F given E equals the probability of E and F. Okay? No need to memorize two things when it's really the same thing. Okay? All I've done, I just multiplied both sides by the denominator here, and I got the same thing. And then I gave it a new name. Okay? So, let's do another example here. How about, what if I told you that the probability of the driver, a speeding driver, gets pulled over equals 0.8. I don't think it's that high, do you? How about 80% of you get speed and don't get pulled over? So let's just pretend. Okay? Let's say that the probability that the driver gets a ticket, given that they were pulled over, equals 0.9. Okay? What is probability that a driver who is speeding gets pulled over and, capitalize that and, gets a ticket? Okay? So let's identify our events again so that we can plug it in one of these two formulas. Okay, so Megan, I always like to start with the given one, right? Okay, so let's label these events E and F, which one's which? So the driver gets a ticket is event,
F.
what?
Ticket is F.
Ticket is F,
Hold over.
hold it over is E, so this is event E, okay? And I want event E and F, right? That's the probability I want. So which equation do I use?
The general multiplication rule.
General multiplication rule, which says probability of E times the probability of F given E, okay? Probability of E is 0.8. Probability of F given E is 0.9 equals 0.72. Probability that the driver is speeding and gets a ticket. Okay? All right, got one last thing I want to do really quickly. So, yeah, I'm going to erase this. Okay? Now, let's say that a survey of 10,000 African Americans shows 27 have sickle cell anemia. Okay? So the probability that an African American has sickle cell anemia is simply 27 over 10,000. Okay? Now my question to you is, what's the probability that 2 African Americans have sickle cell anemia? Okay, I'm going to do this quickly because I know we're out of time. Now the question is, can I assume that they're dependent or can I assume that they're independent? We're going to do this both ways to see what the difference is. Okay? If I assume that these are dependent, what's the probability that the first African American gets sickle cell anemia? Brandon. 27 out of 10,000. What's the probability the second one gets it? 26 out of 99.99. If I assume that they're independent, it is 10,000 and 27 out of 10,000. Okay? Now I punch it in my calculator and I get 1, 2, 3, 4, 5, 702. And I get 1, 2, 3, 4, 5, 729. Look at those numbers. What do you think? It was pretty close? Okay. Which calculation would you prefer to do? Independent. We like independence. It makes our life a lot easier. Okay. So here's the deal. If you can assume independence if your sample size is large enough. What's large enough? Okay. If your sample is less than 5% of your population, you can assume independence even though technically it is dependent. Okay? So finally, the last thing I want to do is the conditional probability rule, which basically says if the probability of E given F equals the probability of E, or the probability of F given E equals the probability of F, we can assume independence. Okay? Because essentially what we're saying here is F has no impact on E, it's the same probability. And once again, E has no impact on F. Does that make sense? All right, so there you have it. Quiz tomorrow on 5.4. See y'all tomorrow.